In this next example, can I please get you to fix the typo? It says find the shaded area between the y-axis. That's clearly wrong. It's very confusing about what the shaded area and the y-axis would be, and it's far too complicated. So please change that to find the shaded area between the x-axis and the functions y equals minus x squared, blah, blah, blah. So we can see that we have what can we see? We can see that we have an upside down parabola, and let me just identify that one, the upside down parabola. So you can see that from the graph that there's a time when the upside down parabola is the bottom boundary of a region, but then there's a second situation where the upside down parabola is the top boundary of the region. And we have an up the right way parabola which sits here, and likewise you can see it is the top boundary of the first shaded region, however it's the bottom boundary of the second shaded region. That then would give us, and if you need to take the time to solve these simultaneously to find the points of intersection, and I suggest you pause the video and do that, you will find that they do intersect at x is equal to 2 and x is equal to 4. So you can spend some time confirming that. I won't go through that on this video. We've done lots of solving equations. So the shaded area then becomes, we've got two areas that we need to add. So I'll have one integral, and and I know I need a lot of space, I'll be adding a second integral. The first integral, the x values will go from 0 to 2. The second integral, the x values go from 2 to 4. Now, we've got to get the right order. We know the top boundary is the up the right way parabola for the first region. So that is your top, which is x squared minus 8x plus 12. Subtract, and again, can't emphasize enough the importance of subtracting here, because actually, look at what we're subtracting. We're actually subtracting a negative, whoops, well, it's not happy. Negative x squared plus 4x minus 4. Now I can be very confident that if you do not have the brackets there, then you're probably going to have some incorrect signs. In the next one, the next region going from 2 to 4, our top boundary is the upside down parabola. So we will have negative x squared plus 4x minus 4 starting this time, and we're going to subtract. Anytime I'm ever subtracting more than one thing, I will put it in a bracket. The thing I'm subtracting is the up the right way one, which is your x squared minus 8x plus 12. So once we've got the actual integrals set up, then it is a matter of being careful, expanding brackets, grouping together like terms, and then eventually taking the integral of the simplified expressions. After that, we substitute the values in, again being really careful because we'll be subtracting more than one thing using the fundamental theorem of calculus, and tidying all of that up. I'm going to pause the video and write the solution up and come back and talk about it. So you can see there I've got my two integrals being added. I'm still simplifying my expressions before I integrate, so I still need my integral sign, 0 to 2. Just collecting like terms, and then adding and doing the same here, collecting like terms. It could be tempting here, I'm not sure if you can see that, if I took a negative 2 out, then that would be x squared minus 12x plus 16, which is the same expression there. However, we can't do anything with it, although they're both exactly the same, because the limits are different. you will see when you get a bit more experienced. Oh no, actually I think we have looked at the law that says you could group them together if they're over the same range. So if that was 0 to 2, that was 0 to 2, we would be able to put them together. So although they could look exactly the same expression under there, the fact that they're over different limits means we can't do anything really with them. So then on the next line you can see I've actually integrated these expressions, added 1 to the index, divided by the index, and done some simplifying where needed. I'm not showing the substitution of the numbers because I know it works, and it'll just take up too much time on the video. I strongly would suggest that you do it. Maybe I don't know, you don't really need to pause the video, but at the end of the video, just see that you can substitute into these expressions. Remember me saying that, you're really not in a position to take shortcut because you haven't done enough practice at these very involved algebraic situations? Well, the same applies here with integration. You really do need the practice. The only way you'll get better and more accurate is to practice. So you need to spend a lot of time practicing. So please do the substitution and make sure you can get the correct answer of 16.